So in this video, we're looking at declining balance depreciation. So this is when the value of an item decreases by a fixed percentage each time period. So this works very similarly to compound interest, but we're going down instead of up. So we still have an original price. We still have a constant rate. But this time the formula is still using the new balance to calculate the next amount. But while interest keeps increasing in compound interest, the depreciation amount keeps decreasing in declining balance. So if $100 decreases by 10% each year, the first year it will lose 10% of its value. In this case would be $10 and become $90. In the next year, the new amount of $90 will lose 10% of its value, which is just $9, and become $81. The depreciation amount will keep declining. So it goes from $10 the first year, $9 the second, $8.10 the next, and so on. So the formula we use for this is S equals V sub 0 outside of 1 minus R to the power of N. So what each letter means here, S is the salvage or current or book value, and that just means the new value after the depreciation has occurred. So what value is left over once it's gone down in value. V sub 0 is the purchase price, which is before any depreciation has occurred. So the reason it has a 0 there is because that's after 0 time periods. So this is right at the very start. The R is the rate of depreciation per time period, and we write this as a decimal just like we do with compound interest. And again, like compound interest, N is the number of time periods. So what this actually looks like, there's a few different kinds of questions you will get that are using different parts of this formula. So probably the most basic kind is if you're just finding the salvage price after depreciation. So it's very similar to finding the future value when given the present value. So a car is bought for $25,000. It depreciates at 12% per annum. What is the salvage value of the car after 3 years? And it tells us to answer to the nearest cent. And with most money questions, that's going to be the case. They want the nearest cent. So it's going to be 2 decimal places. So first thing, we write our formula, which is S equals V0, 1 minus R to the N. So we know that the V sub 0 is $25,000. That is the value when time is 0. R equals 0.12 because that's how we write 12% as a decimal. And N equals 3 because we have 3 years. So we substitute in what we know. So we get S equals $25,000 outside of 1 minus 0.12 cubed. We run this through the calculator and this is our result. Because we're talking about money, we'll put a 0 on the end there. So we get the salvage value of the car after 3 years is $17,036.80. Another kind of question will be asked is finding the depreciation amount. So how much value was lost. So this is simply the difference between the original value and the salvage value. So if you want a formula for it, it's D equals V0 minus S. So the original value, take away the salvage value. So in the previous problem, the original price was $25,000 and the salvage price is $17,036.80. The depreciation is simply how much the value decreased over this period of time. So D equals 25,000 minus our salvage value, which leaves us with D equals $7,936.20. So that's just the actual amount that it went down by. So finding V0, that's the original price before depreciation. So Greg is selling his 5-year-old laptop for $300. It has been depreciating at a rate of 30%. How much did he buy it for? Answer to the nearest cent. So it's very important that we realize what all of our variables are in this case. So again, it's always good to write the formula. It's going to help you remember it. So we start with that. S equals V0, 1 minus R to the N. So in this case, S equals 300. So that's our salvage value. That's how much we're selling it for. So that's $300. The rate is 30%. So we write that as 0.3. And it's a 5-year-old laptop. So we have N equals 5. That's how long it's been depreciating for. So we sub them in the correct places in the formula. And that is going to give us an equation that we need to solve. So we have 300 on the left equals v sub 0 outside of 1 minus 0.3 to the power of 5. So that means we need to divide by the part that's multiplying by v sub 0 at the moment. So that's 1 minus 0.3 leaves us with 0.7, and that is raised to the power of 5. So this whole bit we are dividing out by. So we have 300 over 0.7 to the power of 5 will equal v sub 0, which is what we're trying to find. So that's good. Once we do the division, we end up with a mess, but we are told to round to the nearest cent. So Greg bought his laptop for $1,784.98 because that 9 bumps that 7 up to an 8. So that's the second kind of problem you might be given. The third might be finding the rate itself. So what percent it was depreciating by each time period. So Danny bought a TV for $4,000. After 8 years, he sold it for $1,000. What was the rate of depreciation? Answer correct to 2 decimal places. So we're still answering correct to 2 decimal places, but this time we're not finding a dollar amount, we're finding a rate, but we'll get back to that. We always just start with our formula. So S equals V sub 0 outside of 1 minus R to the power of N. We needed to find our variables. It's going to make it easier if we write them out like this before we start substituting. So V sub 0 is the original price, which we are told is $4,000. The selling price or the salvage price was $1,000. And the number of time periods was 8 because we had 8 years. So now we just need to substitute in and solve. So I've got 1,000 on the left equals 4,000 outside of 1 minus R to the power of 8. So we need to get R by itself. We need to work from the outside in. So first thing we're going to do is divide by that 4,000. That's the easiest thing to get rid of. So we'll divide by 4,000. Obviously 1,000 divided by 4,000 is going to be a quarter, which we'll write as a decimal for ease of writing. So 0.25 equals 1 minus R to the power of 8. So we need to get rid of that power of 8. So we need to do the 8th root. So that needs to happen to both sides. On the right, it's just going to cancel out that 8. On the left, we have to do 0.25, 8 rooted. So bit messy, bit of a mouthful. So we have 0.840 dot dot dot. Remember, we show we have an unrounded answer by writing a dot dot dot. So that just tells other people that we haven't rounded it yet, but we are going to use that unrounded answer to the very end. And we only round at the very end, otherwise we've created error. So that's what we get so far. But on the right, we're left with 1 minus R. So we kind of have to do some maneuvering to get R by itself. So we'll add R. It's going to go to the other side. So now we have that unrounded answer plus R will equal 1. Now, all the while, you should keep this unrounded answer on your calculator screen. So you're ready for the next step. So we're getting R by itself. We now need to take away that unrounded answer from 1 to get it away from that R and keep the R by itself. So this is when you would go 1 minus and then your answer key. So you're using that unrounded answer. Otherwise, again, you created an error there. So we use the unrounded answer by going 1 minus answer. And then we get an unrounded answer still. And then we have to make sure we're in the correct form and the correct decimal places. So normally we talk in percentages for rates. So we are just going to times by 100 to turn that into 15.91%. So when you are writing out your unrounded answer, make sure you add enough digits that you've shown how you rounded it. So in this case, because we were rounding after that 1, we needed the 0 there to tell us what it's going to round to. So write out enough digits that you know what your rounded answer is going to be, and then do your dot, dot, dot after that. And then always good to have a summary statement. Therefore, the rate of depreciation was 15.91%. So finding N, which is the number of time periods. This is actually beyond the scope of this course. So if you think the question is asking for this, you need to read the question again because they're not going to ask you that because it is too difficult to find out. So that's more of an advanced topic.